Okay, I said I would go through this bottom part with you guys so you have the answers, just like we would let me make this a little smaller since you guys can pull it up on your own. But we are looking at the rock classification. We're trying to finish these last couple questions. We already identified that our extrusive igneous rocks, so the ones that have exited the volcano, are going to be up at the top here. Intrusive, it's underneath the ground, it's inside intrusive igneous rock. You have sedimentary over here where the water has carried down pieces of dirt. And then metamorphic is going to be pushed underneath. There's a lot of pressure above it pushing down, and then it's also like right next to the magma chamber, not melting, but kind of getting toasty because of its proximity, its closeness to that melted rock. All right, so we're going to make sure that we show classification names. Got it. My status is on. And then you're going to drag the rocks from the simulation plane to the correct positions on the location tab. Click on status to check your placement. When you are done, click tools and take a screenshot. So we're popping that in there. So this has large crystals. I'm going to say it's intrusive. Bam. We are correct so far. This has pieces of pebble. We said that's sedimentary rock, so that's gonna go over here where that sedimentary rock is, where sediment is carried off of the mountain and dropped into the bottom there. This has layers and is called schist. Those layers show up because of lots of pressure, so we're gonna put it over there. Sandstone, made out of sand, that's sedimentary. Boom. Granite. Granite has big old crystals in it. It's an igneous rock, and if it's crystals that I can see, I'm going to put that down at the intrusive section of these rocks. Slate. Slate is metamorphosed shale. So shale would be a sedimentary type of rock. We put some heat and pressure on it, and we get slate. Boom. Siltstone is made out of silt, so pieces of sediment. So we're going to put that in the sedimentary area. This has pieces of shell in it. You can see the limestone has shell in it. We're going to put it by the water because there's shells in it, and shells are found in the water. So this gneiss has a lot of great layers created by the pressure of rock above it pushing down. Here we have pumice. It has holes in it. Remember, extrusive igneous rock can have holes in it as gas bubbles from the lava escape and solidify into a solid. Marble is going to be metamorphic rock that has been changed through heat and pressure. And then this last one, basalt, also has those little holes in it. So we're going to put it with the extrusive igneous rock. So we need to take a screenshot. There's two ways you can do that. You can do that by hitting this and then copying it. Copy image, pop it in there. You can also do Control Shift and then that bar at the top of the line where there's a box and two lines after it will get you the screen darkened like this. You take a screenshot, drag and drop what you want. You'll have a box pop up in the bottom that says copy to clipboard. You'll copy it to the clipboard, and then you'll put it right next to this image here. Boom. Look how beautiful. We crushed that. Okay. Which rocks did you classify as extrusive and intrusive igneous rocks? So we got to go back in here. Remember that intrusive means it's inside. So gabbro, we're going to put with intrusive. Gabbro. Bruh. And then granite, we also put as intrusive. Granite. And then extrusive is pumice. Pumice is if you've ever gone to get a pedicure and they scrub your foot down with a rock, has little holes and is like abrasive, that's pumice. So that's one place you find that. And then basalt. Okay, what features did you use to classify the igneous rocks as extrusive or intrusive? Well, when we look at these guys, intrusive rocks have these big old crystals that you can see. Intrusive has big interlocking crystals. They're going like this. They're growing on top of each other and whatnot, all right? Extrusive, let's look. Whoa. Has not a lot of crystals, but there might be holes. Has not a lot of not visible crystals. Has holes. All right, the last part here. Extrusive igneous rocks often have air pockets, but intrusive igneous rocks never do. Why do you think this is the case? So I'm going to tell you right now, it's a lot like if you've ever shaken a 2-liter soda. You'll notice down at the bottom of the soda, so like if this is my soda and I shake it up, there's going to be bubbles that come up to the top. And down at the bottom here, where the bubbles might originate, they're very small. You can't even really see them. As they rise up, they're going to expand and get bigger and bigger and bigger. So what you're seeing is as magma moves to the Earth's surface, bubbles or bubbles of air might come out of solution. So those bubbles, any kind of bubbles are going to come out of solution. When they reach the surface, lava cools quickly and will kind of like solidify the pockets of air as they come out of solution. Boom. All right. This is the rest of that lab. Go ahead and finish it, submit it, get those points. Have a great day.